from, and even whether or not there might have been life there at one point.
You mentioned spectral fingerprints. What does that mean?
We've all seen rainbows. We've probably all in science class done something with a prism where we broke up sunlight into many different colors.
Right.
What most people don't know, though, is there's more than those 6 colors: red, orange, yellow, green, blue, violet. But our eyes can't necessarily see all these hundreds of colors. However, we can make instruments and machines that can pick out all these colors. And some of those colors are particularly indicative of certain minerals, especially minerals that formed in water.
And all this investigative work, I mean, finding out about if water was on Mars, how long it's been there. What does this tell us, and why do we care?
It's not enough to know that there was once water flowing on the surface of Mars. Just by looking at certain features on Mars, we could actually tell that there might have been some kind of liquid flowing on the surface, especially right here in this region, where there are things that look like riverbeds, or in here, this whole region resembles parts of the Earth where there have been catastrophic floods.
You know, Deborah, I have a feeling that what we find out about the history of Mars can only give us insight into our own planet. Thank you so much.
You're welcome.
One of CRISM's recent accomplishments was helping to find the perfect landing spot for a new Mars visitor. One that is currently on the surface of Mars, scooping up those minerals we were just talking about and discovering water.
NASA's Phoenix mission to Mars definitely caught the world's attention. I mean, discovering water on Mars, man, it's incredible. But before the Phoenix mission, there were the Mars rovers, NASA's twin robot geologists. They have wheels to get around, cameras to see. They even have robotic arms to pick up samples. It's almost like having humans up there. So what does it take to build a rover like that? Follow me. There she is. Just the person I was looking for. Jessica, how are you?
See you.
Good to see you. She worked as an engineer on the Mars Rover project. All right, so building something like this, I mean, there's a lot of elements to consider.
Right.
What does it take to build something that's almost human-like?
Well, that's a very good point. You know, we aren't sending humans to Mars right now,
Right.
and we need to build a spacecraft to go explore in the same sense that we would explore ourselves. So we need to think about visuals. How are we going to decide where we're going to go? We need to be mobile. We need to have a mobility system to be able to drive around for the rover case. So we have these cameras that we're able to span out across the horizon, pick our next target. We have an autonomous navigation system which allows us to drive with no instructions throughout the day. We just pick that target, drive off to that area. We have solar panels that allow us to keep charging every day so that we can run as long as the soil will allow us. You need to think about the way that you communicate back to Earth. So we have our antenna system, our telecom system, and then you need to think about, well, what's the science that you're doing? And so, you know, just like a geologist in their, you know, tool belt has all these different types of instruments, we pack them on our robotic arm on our rover.
Sure.
So if you can imagine the robotic arm, just like a human arm, shoulder joint, elbow, wrist, and then the hand is a collection of, in this case, 4 different types of devices.
Jessica, what's next for Mars?
Right, so we have the two of these rovers that are currently on Mars, the Phoenix landed mission, and what we're working on next is a rover that's probably about twice the size of this rover. And what we'll be able to do with that is, with a bigger mobility system, a bigger engineering mobile type package to get around Mars, we'll be able to go to those interesting places that are even further from where we land.
Thanks a lot. Although the technology is mind-blowing, the star of the show, the reason the arm works so hard, it's all about the water. All right, so we're here at the Mars Area with Dr. Ashwin Vasavada. I mean, it's a simulation of Mars. It's very dry and rocky. Dude, are you sure there's water on Mars?
That's a good question. I mean, you wouldn't think so if you looked at this.
No.
And in fact, a lot of Mars today looks just like this. But the key is that when we look at Mars from orbit with instruments like CRISM and other big high-resolution cameras that we have in orbit, we can tell that a few billion years ago, perhaps, in ancient early Mars history, it looks like there's water all over the place. We see evidence for rivers that are now dry, see evidence for maybe shorelines of ancient oceans, lakes that are no longer there, and that's the kind of place we want to target with the Mars Science Laboratory. Go to one of those places and try to figure out what exactly the environment was like a few billion years ago.
So what are we learning up there? It's going to help us down here.
Well, I think the thing to keep in mind is that Mars and Earth are more alike than they are different.
Okay. Interesting.
In fact, we consider Mars the most Earth-like planet in the solar system. So we're going to have a team of about 200 scientists working on this mission when we actually land.
So what kind of tools does the Mars Science Lab use?
Well, what we really want to do is study the rocks and soil. Because
Okay.
if there's any clues to what Mars was like a few billion years ago, the clues are going to be in the rocks and soil. So we have a rover that can drive around up to a rock it thinks it looks interesting, or a patch of soil it finds really interesting. And we drive up to it, and then we can scoop up some of that soil, or we can drill into the rock and capture some powder from the inside of that rock, and actually deliver it to the rover itself. And we have some fairly big scientific instruments inside the rover that can study the chemistry of that sample and look basically for clues of whether water was there in the past, or what the temperatures were like, or other hazards or things that are good for life.
Thanks a lot, Doc.
You bet.
Right on. Hey, we've covered a lot of territory today, but you know what's cool and exciting? The process of how we're learning. And yeah, man, science is a process. But you know, now more than ever, the sciences are interdisciplinary, meaning the astrophysicists are working with the geologists, who are working with the oceanographers, who are working with the astronomers. You see how it all comes full circle? That's it for this episode. For Jennifer Pulley, I'm Johnny Alonso. Catch you next time on NASA 360.
To understand how water might exist on a planet like Mars, scientists need to study the phone.
I want to show you something. What do you think?
Cell phones, GPS satellites, and yeah,
Sunglasses are a NASA spin-off. How do I look?
I should walk off right now. It's red. It's rocky. Oh, thanks, Christina. Oh, apparently it's full of water. And I'm Johnny Alonso.
And I'm Jennifer Pulley. Oh, she's gonna hate me for that. I swear she's gonna kill me. I'm done.